Okay, guys, so if we look at 18 and 19, for 18, the question wants to know what the height of that truss is. So the height is here, right? It's this length. So do you see anything there that would show you how to calculate what that length is? Okay, so let's try this. We know that this line, I cannot draw a straight line, is perpendicular, right? And the way that we know that is because we can see that it divides these two sides, or this side, sorry, into two congruent parts. It's a bisector. And it comes from angle D down, okay? So it's going to be meeting at a perpendicular angle or a 90-degree angle. So what we have now is two right triangles. So can we use something to calculate the length of that side now? Yes, Alicia, Pythagorean theorem. So you're going to use a squared plus b squared equals c squared. And then solve for b. So does that make sense for number 18? Okay, now to find the centroid, if you flip in your book, remember the centroid is the point of concurrency of all of the medians of a triangle. That's on page 321. So the centroid is what we were working with yesterday in class when we did that activity with the triangles, where we measured all of the medians, and the point where all of the medians met was we calculated what proportion it was in from the angle or in from the side. Do you remember that from the worksheet? So that's what you're going to do for this one. It's very similar to the warm up you did yesterday too. So you guys good with 19 now? So for number 19, it does not want to know the proportion though. It wants the number, just like we did in the warm up. Bye, Campbell. Hey, Lily, we're not doing the bookwork. Remember, we're doing the practice A worksheet instead. So Charlotte Ann, for number 18 and 19, if you look at the picture, we know that D, or we can tell by looking at the picture that D is going to be perpendicular with FE down here. So what we have is two right triangles, okay? So then we can use Pythagorean theorem to solve for that missing side. And then for 19, that's going to be like the warm-up we did yesterday in class. You're going to have to multiply by the proportion in order to see what distance it is from that angle. Yeah, Isabel, let me pull that up real quick, okay? So for number 9, it wants you to measure the distance from the midpoint of the side of your triangle into point P, which is that centroid or the center point that you marked where all of your medians cross. Okay, sorry, number 10. So for number 10, you're supposed to find the relationship between the lengths. So you're going to set up a proportion, and you're going to have the measurement that you took in step 8. You're going to put that over the measurement from step 7. So it's going to be the part of your the part of your median over the whole length of the median. Okay, Lily, so for numbers 9 through 14, we are looking at a triangle that has the medians drawn into it, just like we did the triangle in class yesterday together. So have you gotten totally through that worksheet yet? Okay, that worksheet will help you be able to solve these problems, these parts of it. Have you watched the Edpuzzle video yet? Okay, the Edpuzzle video will also show you how to do these, okay? When you are dealing with medians in a triangle, flip in your book to page 321. You see theorem 5.8? Okay, so for that theorem, you see down at the bottom of the green box where it has AP is 2/3 of AE, BP is 2/3 of BF, and CP is 2/3 of CD. Okay, so that's going to be what you use to solve these, well, mostly what you'll use to solve these problems. So when you draw a median in a triangle, all of the medians intersect at a point that is 2/3 the distance from the vertex to the midpoint. Okay, so remember, these are the vertexes of our triangle. So this point where they intersect is 2/3 the distance from the vertex. Okay, so if we have this whole length here, then this part of it here is 2/3 of the length. And then this part here is 1/3 of the length. So what you're going to do is use the measurements that the problem gives you to try to see, you know, what's 2/3 of this length, or what's the whole length if we know that 2/3 of it is 4, that kind of thing. So another thing, if you look at your, look at the theorem again, where those medians intersect the sides, remember it bisects the side, or it's a midpoint in the side of the triangle. Do you remember we calculated that yesterday? Okay, so we also know then, looking at our picture, that this and this are congruent. Those two parts are congruent, and that these parts are congruent, okay? So now we've got our picture kind of marked up, so we can look at it and see, all right, now what do we know about RV? RV is this length here, right? It's got one tick mark in it. So we have another part that only has one tick mark. So how long would RV be? Yes. So then for SU, SU is this length here, right? Well, we said that that's 1/3 of the whole length. Or another way to think about it, if you have something that's divided into 3 sections, let's see, maybe this is better. Pretend these sections are even, okay? So if I know 2/3 of it equals 4, and these are equal, so this would be 2 and this would be 2, right? Okay, so if this part of it is 2/3 and this part of it is 1/3, this part is also 2. Does that make sense? So what we did is we used the numbers here that we know that this portion is 4, okay? And what we're solving for is this portion from S to U, which is 1/3 of that whole length, which is 2. So SU equals 2. Does that make sense? Okay, so it's not 1/3 of 4, it's 1/3 of this whole length from RU. So if we know that this whole length, 2/3 of that whole length is 4, 1/3 of it is what we had to solve for. So we said this whole part down here is divided into 3 segments, 1, 2, 3. Well, we know these first 2 parts here are 2/3 of that whole length, right? So if 2/3 of the length is 4, well, we know that if we're dividing the whole length into 3 even parts, then we know that 4, or the 2/3 part of it, is divided into 2 even parts, which are 2 and 2. Does that make sense? Okay, you're good now? Okay, so try looking at the rest of them, knowing that information, and see if you can figure out 11 through 14. So for 13, we're finding TS. Let me erase some of this here in the middle. For 13, we're looking at TS, which is from this vertex down to this point, okay? Now, the problem tells us that TV is 9, okay? So the whole length is 9. And it's divided into 3 equal parts, okay? So from the angle down to the centroid is 2/3, and then from the centroid, the rest of the way is 1/3. So this part here is TS. This part is SV. So if we know that the whole length equals 9, but we need to divide it into 3 parts, okay? 9 divided by 3 is 3. So we know SV is 3. And we know this part TS is 2 of those parts, or 6. Does that make sense? Yes. Okay, Lily. So on number 4, you're supposed to find the length of the median CD. So you're going to have a line that connects point C with point D on that other side. Just like we did on our triangles yesterday, we drew from the vertex across to the midpoint of the other side. And then yesterday we just used the ruler on the protractor to measure that length. But when you're asked to find the length of a segment and you have coordinates, like you have your 2 points that have your X and Y value, you're always going to plug into your distance formula. So Natalie, on that one, did you draw your picture? Okay, so when you draw that, tell me, does QR go from the vertex to the centroid or the side to the centroid? Okay, it goes from the side to the centroid. Now, look at your theorem 5.8 in your book on page 321. Yeah, it's 1/3. 2/3 is the measure from the angle to the centroid or the vertex to the centroid. 1/3 is the measure from the centroid to the side. You're welcome. So Lily, on 15, they want to know if BD is a median of ABC, is it an altitude, and is it a perpendicular bisector? So you're going to have 3 answers for number 15 and the same for number 16, okay? So in order to find out if it's a median, an altitude, or a perpendicular bisector, let's look first at what a median is, okay? So if you look at page 321, a median, you can see the definition there at the top. Do you see it there? Okay, so your definition of a median says it's a segment that goes from the vertex to the midpoint of the opposite side. So does BD go from a vertex to the midpoint of the side across from it? Remember, your vertex is the angle or the point of the triangle. And if it goes to the midpoint, then we would know that because the other side would be broken into 2 congruent segments. And we can see that that's marked there. So BD is a median. Okay. Now let's find the definition of an altitude. So look on the next page, on page 322. An altitude is the perpendicular segment that goes from a vertex to the opposite side or to the line that contains the opposite side. So in this case, yeah, it would be yes, it is also an altitude because it goes from the vertex or from that angle, and it's perpendicular, it's marked there, and goes to the opposite side. So then the last part is it a perpendicular bisector? So we can see that BD is perpendicular, yeah, and it's a bisector of that other side, so it is a perpendicular bisector. So it would be yes for all 3 of those on 15. And then you'll follow that same process for 16. Okay, so for 17, this is one where you kind of have to look at it and figure out what is wrong there so you know that something is incorrect. So when we look at that, it tells us that D is the centroid of triangle ABC. Your friend wants to find the length of DE. The median BE has a length of 24, and then find and correct the error. So if we look at this, what do we know about the proportions of a median. That's from theorem 5.8 on page 321. Okay, it's divided into thirds. Which part is 2/3? Is it the part that goes from the angle to the centroid or the part that goes from the side to the centroid? Two-thirds is the side from the angle or the vertex to the centroid. So look at that equation or that formula that they have there and see, is that talking about the part of it that goes from the angle to the centroid, or is that talking about the part that goes from the side? Well, so DE is the part that goes from the centroid to the side. Okay, so that's going to be, DE should be 1/3 of the whole length of that median. So what they did is they have, you could do it one of two ways. You could say that it should be DE equals 1/3 of BE, or it could say that BD equals 2/3 of BE, and then you would have to solve through and then subtract from the whole amount to find what's left. Does that make sense?